Welcome to qnawire.
Hello, today we'll be continuing our discussions with probability distributions, and we will be doing an example today where we will be constructing our own probability distribution, with this example that will include determining all the probabilities for each possible x value and determining what those x values will be. And our example for today is that 6 numbers, 1, 3, 6, 10, 15, and 21 are each printed on a card. So there are 6 cards. The cards are shuffled randomly face down, and then 2 cards are chosen, and the sum of the 2 card values equals x, which is our random variable today. We will be constructing a probability distribution for that random variable x. So to start approaching this problem, we need to write out the sample space for this example, as well as sum together all the possible values of x. We'll start this with, let's draw 1, 1, 1, 1, plus 3, plus 6, plus 10, plus 15, plus 21. Now we have to be careful to be sure we do not double count any instances in the sample space. So I do this by adding all the values together the way you're seeing here. I go through all the instances. We can have a distinct pairing with 1, then a distinct pairing with 3, which now goes down to 4, because we already used one of them here for our 1s. So anyway, 3, and then 6, 10, 15, and 21. We just continue this with all of our values until we run out of combinations. 15 plus 21, 10 plus 15, 10 plus 21, and then 15 plus 21. So our number in our sample space, we can count it out, but our number in our sample space is that we have 15 possible values of x. And now we'll go ahead and add everything together. 4, 7, 11, 16, 22, 9, 13, 18, 24, 16, sorry, yep, 16, 21, 27, 25, 31, and finally we have our 36. Now one thing you'd notice is that it appears we have a lot of distinct values of x. We only seem to have 1 or 2 instances of repeating numbers. That's it. So basically all of our values, with the exception of x equaling 16, every other value our probability will be 1/15th, whereas 16 will be 2/15ths because we see it 2 distinct times. Now we'll be drawing out our actual probability distribution, which once again, we have our random variable at top and our probability of each x value in our lower portion. Oh, there we go. Sorry guys, there we go. And we'll have to be pretty small with our writing on this one. So we have 4, 7, 9, 11, 13, 16, 18, 21, 22, 24, 25, 27, 31 and 36. I know normally we don't put lines between these values, but because of how kind of squished we are, I'm going to go on ahead and do it just so that we don't get mixed up with all these two-digit numbers. And then now for our probabilities for each one. As we mentioned previously, number for 16 is the only one that will be 2 over 15. And our other remaining 13, I believe, values will be 1 over 15. Here we go. Sorry, these are both 15s. Sorry. There we go. And just to double check that we've made our probability distribution correctly, as we recall, every probability in a probability distribution must be between 0 and 1, so it must be positive and less than 1, and they all must sum up to equal 1. And if we add up all our 1s and 2s, we see that they all equal 15. They all add up to 15, and as usual, 15 over 15 equals 1. So we have completed our probability distribution for this problem.